Hey everyone, welcome to a deep dive into a topic that's been generating a lot of buzz lately, and for good reason, quantum computing.
It's definitely one of the most exciting and potentially transformative fields in science and technology today.
Right. It seems like everywhere you turn, people are talking about how quantum computers are going to revolutionize everything, from medicine to material science to artificial intelligence.
And it's not just hype. There's real substance behind the excitement. We've been digging into lectures and papers from some of the leading minds in physics, like Brian Cox and Michio Kaku, and what we found is truly mind-blowing.
I know, right? It feels like we're on the verge of a technological revolution that could reshape our world in profound ways. But before we get too carried away with all the amazing possibilities, maybe we should take a step back and try to demystify this whole quantum computing thing.
Absolutely. A good starting point might be to clarify what quantum computing is and how it differs from the classical computing we're all familiar with.
Yeah, I think that's key because when I hear the term quantum, my brain sort of goes into a temporary freeze. It sounds so complex and mysterious.
It is complex, but it's also incredibly fascinating. At its core, the main difference lies in how information is processed. Classical computers, like the ones we use every day, rely on bits, which can be either a 0 or a 1. It's a binary system.
Like a light switch, it's either on or off.
Exactly. But quantum computers utilize qubits, which can be in a superposition.
Superposition. Okay, now you're really testing my high school physics knowledge.
Think of it like a coin spinning in the air. Before it lands, it's both heads and tails at the same time. That's kind of what a qubit is like. It can exist in multiple states simultaneously, not just 0 or 1.
So it's like it's in this blurry, undefined state until you actually measure it.
Precisely. And this ability to be in multiple states at once is what gives quantum computers their immense power.
Okay, so more states, more power. But how does that translate into solving real-world problems? Like, what kinds of things can a quantum computer do that a classical computer can't?
Well, one of the key limitations of classical computers is that they struggle with problems that involve a huge number of possibilities or variables. Think about simulating the behavior of molecules in a drug, or predicting the weather patterns over a vast region, or optimizing a complex financial portfolio.
Okay, yeah, those are some pretty hefty calculations.
Right. And as those problems scale up, classical computers quickly hit their limits. Even the most powerful supercomputers we have today would take billions of years to solve certain problems.
Billions of years. That's longer than the universe has existed.
Exactly. But a quantum computer, thanks to the unique properties of qubits and superposition, could potentially tackle those same problems in a fraction of the time.
So it's not just about speed, it's about being able to handle a completely different level of complexity.
Exactly. Quantum computers are opening up a whole new realm of possibilities, a new way of thinking about computation.
I'm starting to get it, but I'm sure our listeners are eager to hear about some specific examples. What are some of the real-world applications of quantum computing that have scientists so excited?
One area that's generating a lot of buzz is material science. Imagine being able to design materials from scratch at the atomic level, predicting their properties with incredible accuracy.
So we could essentially create materials with custom-made properties, like a super strong but lightweight alloy for building airplanes, or a material that's perfectly suited for storing energy in a new type of battery.
Exactly. And it goes beyond those examples. Think about designing catalysts that can efficiently capture carbon dioxide from the atmosphere, or developing new types of solar cells that are far more efficient at converting sunlight into electricity.
Wow, that's incredible. So this isn't just science fiction, it's something that could have a real impact on our world.
Absolutely. And the potential applications go far beyond material science. Quantum computers could revolutionize medicine by allowing us to design personalized drugs that are tailored to an individual's genetic makeup.
Now, that's something I think we can all get behind.
Right. And they could also transform fields like finance, logistics, and artificial intelligence, leading to breakthroughs in everything from optimizing investment strategies to developing smarter and more efficient algorithms.
This is really starting to paint a picture of just how transformative quantum computing could be. But as you mentioned earlier, there are some pretty significant challenges that need to be overcome before we can unlock its full potential.
Right. One of the biggest hurdles is something we touched on earlier, which is maintaining the stability of those delicate qubits. Remember, they exist in these superpositions, which are incredibly sensitive to any kind of disturbance from the environment.
So it's like trying to balance a spinning top on a vibrating table.
Exactly. And as you can imagine, that's not an easy task. Currently, most quantum computers need to be kept at extremely low temperatures, colder than outer space, and shielded from any kind of electromagnetic interference.
Wow, so building a quantum computer is a bit like building a spaceship. You need some serious engineering expertise and a whole lot of precision.
That's a good analogy. And as with any complex technology, there are bound to be setbacks and unexpected challenges along the way. But the progress that's been made in recent years has been remarkable, and the pace of innovation is only accelerating.
So it feels like we're at a tipping point. We've got the theoretical foundations, we're starting to build the hardware, and we're beginning to glimpse the incredible possibilities.
Exactly. And as more researchers and companies invest in this field, we can expect to see even more breakthroughs in the coming years. It's a truly exciting time to be following the development of quantum computing.
Well, speaking of exciting developments, there's one particular breakthrough that's been making headlines lately, and it involves this mysterious particle called the Majorana fermion.
Ah, yes, the Majorana particle. That one's definitely captured the attention of physicists around the world.
I'll admit I'm a bit lost on this one. Can you explain what a Majorana particle is and why it's so important for quantum computing?
It's a bit tricky to explain, but in essence, a Majorana particle is a type of particle that is its own antiparticle.
Wait, its own antiparticle? What does that even mean?
It's a bit mind-bending, I know. In the world of particle physics, every particle has an antiparticle, which has the same mass but the opposite charge. When a particle and its antiparticle meet, they annihilate each other in a burst of energy.
Okay, so I'm vaguely remembering that from my physics class.
Yeah.
But you're saying that a Majorana particle is both the particle and the antiparticle at the same time.
Precisely. It's a fascinating concept, and it has some very interesting implications for quantum computing.
Like what?
Well, one of the biggest challenges in building stable qubits is protecting them from noise and decoherence. Basically, any kind of interference from the environment can disrupt the delicate superposition state of a qubit, leading to errors in the computation.
Right, we talked about that earlier, the spinning top analogy.
Exactly. But Majorana particles, because of their unique properties, are thought to be much more robust against this type of noise. They're like super stable qubits.
So if we can harness Majorana particles, we could build quantum computers that are far more reliable and powerful.
That's the hope. And there's been some really exciting progress in that area. Researchers at Microsoft, for example, have been working on developing a new type of qubit based on Majorana particles, and they believe it could be a game changer for quantum computing.
A game changer, huh? So we're talking about potentially building quantum computers that are not just faster than classical computers, but also more stable and reliable.
Exactly. And that could open up a whole new range of possibilities, from designing new materials and drugs to simulating complex systems and even cracking the toughest encryption codes.
Wow, it sounds like the future of quantum computing is going to be pretty wild. I can't wait to see what breakthroughs lie ahead.
Me too. It's a truly fascinating field, and we're really just scratching the surface of its potential.
Well, on that note, I think we've covered a lot of ground in this first part of our deep dive into quantum computing. We've talked about the basics of how it works, the key differences from classical computing, and some of the potential applications that have scientists so excited.
We've also touched on some of the challenges like maintaining the stability of those delicate qubits and highlighted the exciting potential of Majorana particles for building more robust quantum computers.
It's a lot to take in, but I hope our listeners are starting to see why quantum computing is generating so much buzz and why it has the potential to be one of the most transformative technologies of the 21st century.
Absolutely. It's a field that's worth paying attention to because it's going to have a profound impact on our world in the years to come.
And speaking of impact, in the next part of our deep dive, we're going to delve into some of the specific ways that quantum computing could revolutionize different industries, from healthcare and finance to material science and artificial intelligence. We'll also explore some of the ethical considerations that come along with this powerful new technology.
It's going to be a fascinating discussion, so be sure to tune in for the next installment of our quantum computing journey.
Okay, so we've laid the groundwork, but where does it all lead? What are the real-world implications of this technology?
Well, one of the most promising areas is material science. Imagine being able to design materials at the atomic level, knowing exactly how they'll behave before you even synthesize them.
You mean like a super strong but lightweight material for building spacecraft?
Yeah.
Or a superconductor that works at room temperature?
Exactly. And it goes beyond just those examples. Think about designing catalysts that can capture carbon dioxide from the atmosphere or create entirely new types of batteries with unheard of storage capacity.
That's incredible. So this isn't just theoretical. Scientists are actually working on this.
Absolutely, and they're making real progress. One of the key insights from our sources is that quantum computers could drastically accelerate the process of drug discovery and development.
Now, that's something I think we can all get behind. How would that work?
Well, as you know, many diseases are caused by malfunctions at the molecular level, but those molecules are incredibly complex. Simulating how they interact, how they fold, how they react to different drugs is a task that's far beyond the capability of classical computers.
Right. We touched on this earlier with protein folding.
Exactly. But with quantum computing, scientists could simulate these complex biological processes with a level of detail that was previously impossible. Imagine being able to see how a drug interacts with a virus at the atomic level, or design a cancer treatment that precisely targets only the cancerous cells.
That sounds almost too good to be true. It's like having a microscopic surgeon operating at the molecular level.
It's a powerful analogy, and it highlights the potential of quantum computing to revolutionize healthcare.
So far, we've talked about the positive impacts, but we can't forget about the potential downsides as well. What about this idea that quantum computers could crack the encryption that protects our digital world?
That's a valid concern and one that's being taken very seriously. Many experts believe that the encryption algorithms we use today to protect our online banking, our communications, even national secrets, could be broken by a powerful enough quantum computer.
So everything we rely on for security could be vulnerable. What can we do about that?
The good news is that researchers are already working on developing new types of encryption, what they call quantum-safe encryption, specifically designed to withstand attacks from quantum computers.
It's like a cryptographic arms race.
Hmm.
As quantum computing advances, so too must our defenses.
That's a good way to put it. But this is just the tip of the iceberg. Quantum computing has implications that go far beyond materials, science, medicine, or even cryptography.
Okay, you've got me intrigued. Where else could this technology lead us?
Well, one area that's captured the imaginations of physicists and philosophers alike is the potential of quantum computing to simulate the universe itself.
Simulating the universe. Now that sounds like something straight out of science fiction.
It might sound like science fiction, but it's a possibility that many serious scientists are exploring. Quantum computers, with their ability to handle vast amounts of data and explore multiple possibilities simultaneously, could allow us to create models of the universe with unprecedented accuracy.
So we're not just talking about simulating the movement of planets or the formation of stars. We're talking about modeling the fundamental laws of physics, the behavior of matter and energy at the smallest scales.
Exactly. We could potentially recreate the conditions of the Big Bang, study the formation of black holes, even explore alternative theories of physics that are currently beyond our reach.
That's incredible. It's like having a universe-sized laboratory at our fingertips.
It's a captivating idea, isn't it? And it speaks to the sheer power and potential of quantum computing.
All this talk about potential is exciting, but let's be realistic. What are the challenges that stand in the way of realizing these incredible possibilities?
Well, one of the biggest hurdles is scalability. Right now, the most advanced quantum computers only have a few hundred qubits. But to really unlock the full potential of this technology, we'll need to scale up to thousands or even millions of
You
qubits.
can imagine that's no easy feat.
Not at all. There are significant engineering challenges in building and controlling these complex systems, especially maintaining the stability of the qubits. As we talked about earlier, they're extremely sensitive to any kind of disturbance.
So even a tiny vibration or a slight change in temperature could throw things off.
Exactly. Maintaining coherence, as it's called, is absolutely crucial, and that requires some pretty extreme measures. Most quantum computers have to be kept at ultra-low temperatures, colder than outer space, and shielded from even the slightest electromagnetic interference.
Wow, it sounds like building a quantum computer is a bit like building a spaceship.
It's a fair comparison, and just like with space exploration, there are bound to be setbacks and unexpected challenges along the way.
So this is all still very much in the early stages.
Absolutely. We're just at the beginning of the quantum computing journey.
This brings up another question. We've focused a lot on the science and the technology, but what about the ethical considerations? Are there any potential risks or dangers associated with quantum computing that we need to be aware of?
That's a crucial point and one that deserves careful consideration. As with any powerful technology, there's always the potential for misuse.
What are some specific concerns?
Well, for one, the ability to crack current encryption methods could have significant implications for national security and global stability. Imagine a world where governments, or even criminal organizations, could easily access sensitive information, disrupt critical infrastructure, or sow chaos and distrust.
That's a chilling thought. So we need to make sure that this technology doesn't fall into the wrong hands.
Absolutely. And that requires international cooperation and responsible development. But it's not just about preventing malicious actors. We also need to think about the broader societal impact of quantum computing.
What do you mean by that?
Well, consider the potential for job displacement. As quantum computers become more powerful, they could automate tasks that currently require human intelligence and expertise. This could have a significant impact on the workforce and the economy.
So we need to start thinking now about how to prepare for these changes, how to ensure that everyone benefits from the advancements in quantum computing.
Exactly. We need to approach this technology with a sense of responsibility, with a focus on using it to improve human lives and solve global challenges.
These are big questions, but they're important questions. And I'm glad we're having this conversation.
Me too. And I think it's important to emphasize that even though we're talking about potential downsides, the overall potential of quantum computing is incredibly positive. We're on the cusp of a technological revolution that could transform our world for the better.
I agree. And while there are certainly challenges to overcome, I'm incredibly optimistic about the future of quantum computing.
Me too. It's a truly exciting time to be alive.
It's incredible to think about all the potential benefits of quantum computing, but it's also a bit daunting. How do we as a society prepare for such a fundamental shift in technology?
It's definitely a big question. I think one of the most important things we can do is to educate ourselves about this technology. The more people understand about quantum computing, the better equipped we'll be to make informed decisions about its development and use.
Right, because knowledge is power. But it's not just about understanding the technical details, is it? It's also about thinking through the ethical and societal implications.
Exactly. We need to have open and honest conversations about the potential risks and challenges of quantum computing, as well as its benefits. For example, we need to address concerns about job displacement, data privacy, and the potential for misuse of this technology.
It's like any powerful tool. It can be used for good or for bad.
Precisely. So it's up to us as a society to ensure that quantum computing is used responsibly and ethically.
And that starts with education and awareness.
Yeah.
We need to make sure that everyone has a basic understanding of what quantum computing is and how it could impact our lives.
Absolutely. And we need to start early. We need to encourage more young people to pursue careers in STEM fields, especially in areas related to quantum computing.
Because they're the ones who are going to shape the future of this technology.
Exactly. They're the ones who are going to develop the next generation of quantum computers and algorithms, and they're the ones who are going to figure out how to use this technology to solve the world's most pressing problems.
So it's not just about building better quantum computers, it's about building a better future.
Well said. That's really what it all comes down to.
This has been an incredible journey. Thank you so much for sharing your expertise with us. Any final thoughts for our listeners as we wrap up our exploration of quantum computing?
I would simply say this: stay curious, keep learning, and don't be afraid to ask questions. Quantum computing is a complex and rapidly evolving field, but it's also a field that holds immense promise for our future. And the more we understand about it, the better prepared we'll be to navigate the exciting and challenging times ahead.
Absolutely. And on that note, we've reached the end of our deep dive into the world of quantum computing. We hope you found it informative, thought-provoking, and maybe even a little bit mind-bending. We encourage you to continue exploring this fascinating topic and to engage in the conversations that are shaping its future. And of course, don't forget to subscribe to our podcast so you don't miss out on future episodes where we'll unpack equally captivating subjects. Until next time, keep exploring, keep questioning, and keep that thirst for knowledge alive.